Alright, let's look at the telescoping series. Alright, it's probably the easiest to dive right into an example. So here's an example. Alright, summation n goes from 1 to infinity at 1 over n squared plus 2n. Alright, so to find this sum, we have to find the partial sum. Alright, before we go into partial sum, we're going to try to look at the partial fractions so that it's going to make it look a little bit different. Alright, so this is called the partial sum. Oh, sorry, partial fractions. Alright, so let's find the partial fractions of this expression here. So it's 1 over n squared plus 2n. Right? So what we're going to do is I'm going to factor out the denominator. So 1 over. Right? So both have n in it. So I'm going to pull n out. So you have n plus 2. Right? So we can split this fraction into a smaller fraction. So n, so I'm going to basically use the factors on the denominator. So one of the factor is n, and another factor is n plus 2. Right? Then it's going to have some constant here, which we don't know yet, and constant here. Right? So if you have a linear term, it's going to be a constant. So it's going to be 1 degree less, and this is another linear term, so you're going to have a constant there. All right, so let's try to find b. The way to find b is I'm going to actually put this guy back into a 1 fraction by taking a common denominator. So you have that. And then you're going to have to, let's see, you have to multiply a by n plus 2, right, to get the common denominator. And we're going to have to multiply b by n because you have to multiply the denominator by n to get to the common denominator. So I'm going to say bn, right? So you can see that we already have matched up denominators here. So we just need to match the numerators together. All right. So we have this equation. 1 is equal to a times a plus 1 plus bn. Right? Then the easiest way to solve for a and b is this. We can simply plug in convenient n value. Right? Let's say you want to find the a value, so we want to get rid of b, so I'm going to try n equals 0. So if you plug in n equals 0, and you can see that the equation becomes, right, so n is 0, so it's a 2a, and the b times 0 is 0, so that's gone, is equal to, it's supposed to be equal to 1, right? So we already know what the a is. Divide through by 2 to get a is equal to 1/2, right? If you want to find a b value, we want to get rid of a. So what you can do is we can plug in n equals -2, n equals -2, so that we're going to have plug in -2, so you're going to give it 0, and the -2 times b is -2b. And again, it's equal to 1. So we set that equal to 1. And then we're going to divide through by -2. So b is going to be -1/2. Right? So which means that this expression right here, right? So we have this guy is going to be equal to, right? A is 1/2 and b is -1/2. So I'm going to pull out the 1/2 in front. So 1/2 because both of them has 1/2. So a is 1/2, pull out, so it's going to be 1 over n. B is -1/2, pull out the 1/2, so it's going to be -1 over n plus 2. Right? So this is exactly the same expression as 1 over n squared plus 2n. It just looks a little bit different. All right. So this summation now can be rewritten as, all right. So I'm going to pull 1/2 outside of the summation sign. So we can put 1/2 outside. Then we have a summation. N goes from 1 to infinity. Then we have 1 over n minus 1 over n plus 2. All right. Then what we want to do is, again, we're going to look for the partial sum, right? So let's find the Sn. So Sn is going to be, all right, so I'm going to write down the first few terms and the last few terms, all right? And I can multiply by 1/2 later, so I'm going to ignore 1/2 for now, all right? So first term is n equals 1, so it's going to be 1 over 1 minus 1 over 3, right? So n equals 1 here. All right, next term is n equals 2. It's going to be 1 over 2 minus 1 over 4, right? Then next term is going to be 1 over 3 minus 1 over 5, right? And so on. So I'll just say dot, dot, dot. All right, let's write down the last few terms, right? So the very last term is going to be, the last term, nth term is going to be 1 over n minus 1 over n plus 2. All right, the previous term is going to be 1 over n minus 1 minus 1 over n plus 1, right? And one previous term is going to be 1 over n minus 2 minus 1 over n, right? So we have that. All right, and we try to cancel out as many terms as possible. So you can see, so here's the pattern, right? So you have a pair, and the second one, and then if you skip the entire parentheses and then go to the next one, you get the same number except for a different sign. So we can cancel. So negative 1/3 cancel with positive 1/3, right? Right? And unfortunately, this 1/2 would have been paired up with this guy, but we don't have those. So this guy stays. And for the same reason, this guy stays, because there's no one to pair up with. Right here, negative 1/4, and it's the second one. Skip a term, and the next one is going to be positive 1/4, which I didn't write. But we know that this is going to cancel with this guy, and this is going to cancel with the skip one and another one. So there's going to be a bunch of cancellation. And again, this guy is going to cancel with that guy right there, right? And we know that this one right here, skip one and then cancel with this guy. And also this one is going to be canceled with that one. We can't see it, but it's there. All right, but these two will not cancel because there's no one to pair up with. All right, so the partial sum becomes, right, so this is going to be 1 plus 1/2, so it's going to be 3/2. And you have a couple leftover terms. It's going to be minus 1 over n plus 1 and minus 1 over n plus 2. Right? So this is the partial sum. Right? So once you have a partial sum, to find this actual sum of the infinite sum, you just have to take the limit of the partial sum, which is 3/2 minus 1 over n plus 1 minus 1 over n plus 2 as n approaches infinity. Right? So you can see that here, 1 over n plus 1, and it gets larger and larger because denominator is getting larger and larger. This is going to approach 0. and 1 over n plus 2 is going to approach 0 for the same reason. All right, then the limit of the partial sum is only thing left is 3 halves. So 3 halves. All right, this is the sum of the telescoping series. All right. So the reason why this is called the telescoping series is that you can see that you have a bunch of terms and there's some overlap, so it looks kind of like a telescoping series, a telescope, because telescope has a bunch of cylinders. They overlap a little bit with each other. So in this case, overlap being a cancellation of the same term, so you can just cancel them out. So that's why it's called telescoping series. All right, that's it. I hope that this was clear.